Let's do IXL 7th grade AA.2. Go to Learning, go to 7th grade, go down to AA.2, Area of Rectangles and Parallelograms. Okay, before we do that, let's go over to Friedman Math. Make sure that you watch the videos in this section over here. I'm going to have a video called Area of Basic Shapes that you should watch before doing this IXL. And you should also look through the reference pages, which I'm going to do right now. For this IXL exercise, we are going to need to look at area, which is on page 12. So let's go down there. And here we are on page 12. All right, let's just read through this. What is area? Area is the number of square units, squares which are 1 unit long on each edge, that can fit inside a shape. The area of a rectangle is ARECT, means the area of the rectangle, is equal to the length of the rectangle times the height of the rectangle. In the video, I said the base times the height, but you could call it whatever you want. So in this example here, if the base is 6 units long and the height is 4 units long, then how many little squares do we have in here? Well, it would just be 6 times 4, or 24. So we would say that the area of this rectangle is 24 square units. So in general, when you want to find the area of a rectangle, you just do the base times the height. Now for the area of a parallelogram, it's also the base times the height, or if you like, the length times the height. Again, it doesn't really matter what you call these things. Now you should realize, though, this is important, the height is always perpendicular to the length. So for example, if we have a parallelogram here we can see that this side right over here, which is 7 units long, is perpendicular to the line from here to here, which is 3 units long. By perpendicular, we mean that there is a right angle between them. Well, that's hard to see. I'll use a different color. There's a right angle between these two. So if we call this the base, then this would have to be the height, not this. So to find the area of that parallelogram, it would just be 7 times 3, not 7 times 4, not 7 times 3 times 4, just 7 times 3, which would be 21 square units. And so that's all that we're going to need for this IXL exercise. Remember, it's always just going to be the base times the height. Okay, so what is the area of this parallel, which, by the way, sorry, let me just go back here for 1 second. It makes sense that the area of a rectangle is exactly the same as the area of a parallelogram, because a rectangle is just a specific kind of parallelogram. A rectangle is just a parallelogram where the length and the width are perpendicular to each other, meaning they form a 90-degree angle. But a rectangle is a parallelogram, so it makes sense that the formula here is the same as the formula here. All right, so anyway, we have a parallelogram here, and the length is 3 feet, and the height is also 3 feet. So we're just going to do length times height, or I'm going to call it base times height. which would just be 3 times 3, which is equal to 9. And that would be 9 square feet, by the way, because this was 3 feet and this was 3 feet. So feet times feet would be square feet. So we'll put a 9 over here. In other words, we could take 9 little squares, with each square being 1 foot long and 1 foot high, and fit them into this parallelogram. We would have to cut the squares in some way to make them all fit in here, but assuming that we cut them in the right way, we would be able to do it. Okay. What is the missing length here? Okay, so now we have to be a little bit clever here. So again, this is a parallelogram. Our formula is simply the area. I'm going to write the whole equation out this time. The area equals the base times the height. Now, in this case, we're given the area. We're told that the area is 15 square centimeters. And that is equal to the base, which we don't know. That's what we're trying to figure out, the base. So they called the base here U. I'm just going to, I'm going to keep calling it B. Or if you want, I could call the base U. It doesn't really matter. Times the height, which is 5. Okay, so now we have to solve for U. So we're going to divide both sides by 5. And we get U is equal to 3. Now this makes sense, because if U is equal to 3, then we have 3 times 5 equals 15. So that makes sense. So we'll say that U is equal to 3 centimeters, not square centimeters, just centimeters. But they already put the units here for us, so we don't have to do that. Okay, so just talk a little bit about the units there, because we have this 15 was really 15. It was 15 square centimeters, right? And the U was in just normal centimeters, and the 5 was in centimeters also. So when we divided by 5 here, we were really dividing by 5 centimeters. And when we do centimeters squared divided by centimeters, the unit that we get as our answer would be centimeters. Okay, so 3 centimeters is correct. I'm not going to write the units in for every single question. I just wanted to do it that one time to show you that the unit analysis does work out correctly. What is the area of this square? Oh my goodness. Well, we didn't talk about the area of squares, right? All we talked about was the area of rectangles and parallelograms. But again, a square is just a special kind of rectangle, and rectangles are special kinds of parallelograms. So squares, therefore, are also just special kinds of parallelograms. Squares are just parallelograms where the angles inside are all 90 degrees, and furthermore, all of the side lengths are equal. But the formula is going to be the same. It's just going to be base times height. So we know here that the height is 3 yards. That's what they told us right over here. The height is 3 yards. And they did not tell us what the base was. So how are we supposed to answer this question? Well, we know that it's a square. And in a square, all of the sides are the same. So if this is 3 yards from here to here, then this from here to here must also be 3 yards. Right? So we have that the area of the square, I'll just write it all out, even though I don't really have to this time, is the base times the height. This time I don't know the area, so I'll keep the A there. So we get the base is 3, the height is also 3. So we get again the area, just like in the first problem, is 3 times 3, which is 9. And that would be square yards, because we just had yards times yards is square yards. But they told us that they put that in for you anyway, square yards here. Okay, moving right along. What is the missing length? So again, just write out the whole equation. It's not as important to write out the whole equation if they give you the base and the height and you have to find the area. Then you just multiply them. But this time they gave us the area and the base, and we have to find the height. So in this case, it is a little bit more important to actually write the entire equation out with the equal sign here and with the A over here. So, whoops, oh boy. There we go. Okay, so the area is 60 centimeters. The base is 6 centimeters. And the height is C centimeters. And we're solving for C. So this is 6 times C. So the inverse of multiplication is division. So we'll divide both sides by 6, and we get C is equal to 10. So the height would be 10 centimeters, which again, it makes sense because 10 times 6 is equal to 60. So let's put a 10 in there. Okay. So I think we already did problems like this. The only difference here is there's a decimal here. But again, to find the area, all we have to do is multiply the base times the height. All right, so that would be, I think, 30.4. Let me just see if my mental math is good. Yeah, there we go. All right, I'm going to go ahead and we have another square here. Just remember that if you have a square, then this side has to be the same as this side. So this would also be a 6 because this was a 6, right? So we just do 6 times 6 is 36. Let's go ahead and jump to the next level. Oh, they don't give you a diagram now. So you got to read carefully. A square has sides of length 6 kilometers. What is the area? Well, that's just like the last question, except written in words, without the diagram. If we draw the diagram, then again, it would be 6 here, a 6 here, and the area is equal to the base times the height, which is just 6 times 6, which is 36, and that would be square kilometers, because we did this, even though I didn't write it, this would be kilometers times kilometers is square kilometers. So they gave you that square kilometers there as the units anyway. Okay, next one. A parallelogram has a base of 17 kilometers and a height of 19.3 kilometers. What is the area? Again, we're given the base, and we are given the height, right? So in our formula here, the area is equal to the base times the height. We would just have the area is equal to, the base was 17 and the height was 19.3. And by the way, if you put the base and the height in the wrong order accidentally, so if I put the 19.3 here and I put the 17 over here, that would still be okay because of the commutative property. I can multiply these numbers in a different order and still get the same answer. So if you mess up with the base and the height, that's okay, but don't mess up for the area. If you put one of these numbers over here for the area, then you're really messing up. Then you would get the wrong answer. So anyway, let's just do 17 times 19.3. And I don't care if you use a calculator for these problems. This is not really testing your ability to multiply numbers. It's really testing your ability to understand how to find the area of parallelograms. So I don't care if you use a calculator for this one. I'm going to do it. So 328.1 square kilometers would be the answer there. Okay, so this is a kind of a question that I wanted to see. You have to make sure that you are reading it carefully because this is not like the last question. This question says the area is 31.85 square yards and the base is 6.5 yards. So if we have our formula here, area is equal to the base times the height, this 31.85, that is the area. So we got to make sure that we put that in the right spot. That goes here. Okay, if you put that here for B or here for H, you will get the wrong answer. Now the base is 6.5 yards. I'm going to put that here under base. If I made a mistake there and put the 6.5 here for H instead of for B, that would have been okay, actually. I still would have gotten the right answer because, again, because of the commutative property, it doesn't really matter if I put it here or here because these two things are just getting multiplied together. But you really have to be careful where you put the area. You can't put the area in here for the base or the height. You can't mess up there. So now we're just going to divide both sides by 6.5 to cancel that out. So we get H is equal to, and again, I really don't care if you use a calculator here, 31.85 divided by 6.5 is equal to 4.9. I did that in my head, of course. I just wanted to make sure that my calculator thing was working. So I'll put a 4.9 over here. And there we go. Okay, so if we have fractions. Okay, so we'll do a fractions one. It's the same thing. It's the same thing, but with fractions. Just like the last problem was the same thing, but with decimals. So again, we write our formula. Area is equal to the base times the height. This time they did not give us the area, so we'll keep the A there, just the way it was. The base is 1/3, the height is 2/3, so we'll just multiply those together. And when we multiply fractions, we just go zhoop, zhoop. We multiply the numerators together, and we multiply the denominators together. So 1 times 2 is 2, and 3 times 3 is 9. And the units, by the way, would still be square centimeters because we had centimeters here. I'll just write it out, even though I said I wouldn't do that again. We had centimeters here and we had centimeters here. So centimeters times centimeters is square centimeters. It doesn't matter that we're dealing with fractions here. If you have centimeters times centimeters, it doesn't matter if that length is represented as a fraction or as a decimal. You still get square centimeters for the area. 2/9. So 2, and then you have to hit the slash symbol, which on my keyboard here, it is on the same button as the question mark. and then a 9. Make sure that you're hitting the backslash, not the forward slash. Sorry. No, sorry. This is the forward slash. This is the backslash. So make sure that you're hitting the forward slash, not the backslash. So 2/9 there. Okay. All right. So let's practice. Let's practice with mixed numbers. So we have 10. Again, this is just going to be the area is the base times the height. So we're just going to be multiplying these. I'm not going to write out the whole equation again. We would just do 10 3/4 times another 10 3/4. So remember to, when we're multiplying mixed numbers, it's best to turn them into improper fractions first. So we have 4 times 10 is 40, plus 3 is 43. So we have 43 over 4. Keep the denominator the same, times another 43 over 4, because this number is just the same as this one. So we're going to get there. Let's just go ahead and do 43 squared, right? Which, that gave, yeah, okay. No, that's fine. So 1,849. Sorry. For some reason, for a second, I thought it gave me the square root, because usually SQRT is how you write square root. So for a second, I read that as square root. I'm sorry. Sorry to confuse everybody. No, that's fine. So we have 1,849 over 16. Let's go ahead and divide those. So we have 1,849 divided by 16 is, write your answer as a fraction or as a whole or mixed number. Okay, so we're going to have to turn this back into a mixed number. Ugh, that's going to be annoying. So we have to do, I'll do it over here, 1,849 divided by 16. 1,849 divided by 16. So 16 does not go into 1, so we'll put a 0 there. Subtract. Bring down the 8. 16 goes into 18 once. It would be 16. Subtract. We have 2. Bring down the 4. 16 goes into 24 once. We get 16 there. And that's going to be 8. Bring down the 9 over here. And let's see. 16 goes into 89. What's 6 times? 6 is going to give me 96. Now that's so 5 times. So 5 times 16 is 80. And then we subtract, we get a 9 here. So we have nothing else to bring down. If we were doing decimals, we would put a decimal here and a decimal here. But since we're just doing fractions, or a mixed number in this case, we'll keep this as the numerator and put it over our divisor, which will become the denominator. So we have 115 and 9/16. So 115, then put a space, 9 over 16. I hope I didn't make any careless mistakes there. Yeah, there we go. What is the area? Okay, so another one like that. Yeah, I think I'm just gonna use my teacher privileges and skip to the next level, because we just did a problem exactly like this. So make sure that you turn these into improper fractions first, right? you multiply the denominator with the whole number in front and then add the numerator and do the same thing over here. And then you can go ahead and multiply the two improper fractions. And then once you're done with that, divide the numerator by the denominator to turn it back into a mixed number. Or it's possible that you might get a whole number when you do that. I'm going to go ahead and skip to the next level. Which figure has greater area? Okay, so you could just multiply these two numbers and see which one is bigger. So I'm going to just estimate first of all. So I see that 14 is very close to 13.8. So for both of these, the bases, or the bases, I think is how you say it, is plural for base. I'll just say bases. So the bases are almost exactly the same, but the height for this one is much larger than the height for the other one. So we have two bases which are almost the same are going to get multiplied by two numbers where this number is much bigger than this number. So that's going to tell me that after I do that, the area for this one would be bigger than the area for that one, right? Oh, in fact, it has to be bigger because both numbers are bigger. Yeah, you could think of it that way also. So 14 is bigger than 13.8, and 17 is bigger than 10. So actually, both of these numbers are bigger than both of these numbers. So of course, when you multiply these two numbers together, you're going to get a bigger area than if you multiply these two numbers together, right? So 13, I mean, we could just do it anyway. 13.8 times 10, well, that's easy. That's just going to give me, move the decimal one space over because I'm multiplying by 10. That's just going to give me 138. That would be square millimeters if I want to put the units in. And 14 times 17, just go ahead and do that on the side here. That's going to give me 238 square millimeters. So yeah, of course, this area turns out to be bigger than that one. So we'll click on that, hit submit. Which figure has a greater area? Can we say the same thing that we said last time? Well, in this case, this base is larger than this base, but this height, 17.1, is actually smaller than this height, which is 18 feet. So I have a big number times a small number here. Is that going to be bigger than a small number times a big number? This time it's not as obvious, but you could still estimate, and you could say that this height over here is just a little bit smaller than this height over here, right? 17.1 is just a little bit smaller than 18, whereas 17 is significantly larger than 13. So I would say that this area is going to be bigger than this area because the heights are practically the same, but the base here is significantly larger than the base here. But if you want to be absolutely sure about it, you could just go ahead, and I'll use the calculator for this. If we do 13 times 18, that's going to give us 234 for this one. For this one, if we do 17 times 17.1, That's going to give us 290.7. So what did we get for the last one? 234, I think. So this one is bigger than this one. So we'll hit submit there. Which figure has a greater area? So again, it's the same. The idea for these problems really is to try to do it without using the calculator or even without doing it by hand and just by reasoning it out. So here I have to do 17.7 times 17.7. Here I have to do 18.4 times 18.4. So these numbers are both smaller than these numbers. So of course, when I multiply these numbers together, I'm going to get a larger result than if I were to multiply these numbers together. So even without actually multiplying them, I know that the area for this one has to be bigger than the area for that one. All right, I'm going to go ahead and jump to the next level. Please tell me I'm recording and not talking to myself. Okay, good. Sometimes I get paranoid about that. Which figure has a greater area? Okay, so again, I think we did problems like this. Are these? Yeah, so for this one here, it's not as obvious. So here, this height is smaller than this height, but this length is larger than this length. So it's not as obvious this time. If we multiply this and this, if we would get a larger or a smaller answer than if we multiply this and this. So for this one, I would recommend just going ahead. If there's like an easy way to just estimate that, no, I'm not seeing it right now. So we'll just go ahead and multiply those. And I get 504 for this one. And 22.5 squared, or 22.5 times another 22.5 is 506. I think this one was bigger, right? Wait, what did I? Oh my God, I forgot already. Was it 504 for this? Okay, so let me write this down. This is so embarrassing. So this one was 506.25. That was for this one. And the other one was 25.2 times 20. So that should be, well, oh yeah, that should be 504, right? Because it's like 25.2 times 10 would be 252. And then times 2 would be 504. So that should be 504. Okay, so that means that this one is bigger. Okay, all right, so these are all the same. So you could try reasoning some of these out. But if not, you can just multiply the two numbers together and see which one turns out to have a greater area. So that's it. Hope that was helpful. Let me know if you have any questions, reach out, and have a great day.